And we looked at 32 active ingredients representing 28 formulations. And the goal of this study is to generate decline curves and then use MRLs to develop an export guide for industry. We are currently in the process of writing our reports. We plan to make all of the graphs and the guidance available in the new year. Meanwhile, we wanted to show you some examples of the data that we've generated. And one quick caveat before we dive in is to please take this with a grain of salt. Don't bet the farm based on our observations. So with that, let's dive in. So we had 2 different trials take place in Oregon. We looked at the Miko raspberries and Marion blackberries. Was a backpack application. And these samples, since our laboratory is located in Oregon, were so close that we were able to drive down and pick up the samples directly from the station in Aurora. There was one trial that took place here in Linden with Miko raspberries, and those samples were shipped to the lab overnight. And we had 4 reps for each of the sampling events. There was an untreated control that took place, and then samples were taken once dried on the day of the application, and then at 1, 3, 5, 7, 10, 14, and 21 days after application. So here are the list of 15 different insecticides and miticides that we looked at. Most of these are currently registered for both raspberry and blackberry, with the exception of, let me see if I can control this here, of phenbutatin, which is registered for raspberries but not for blackberries. And here's the list of the fungicides, 17 different fungicides that we looked at. Now here we've got a couple, penthiopyrad, where we've recently had some tolerances set for this one, but the registration is still coming. That one's coming soon. Now pidiflumethafen, looks like it's going to be a little bit longer. There's not currently a tolerance set for that one. But when it comes, we expect that it'll be this Miravis Prime, which would be mixed with fludioxonil. Those are the fungicides we looked at. So we received the samples back at the lab. Over the 3 years, all samples were received in good condition. Once they come into the lab, we homogenize those and store them in the freezer. We perform an extraction using the catchers, which is an internationally recognized extraction procedure for pesticides in fruit. And there's a cleanup step with that. All the samples were analyzed by mass spectrometry. And we take great efforts to make sure that we're looking as low as possible. We're getting those limits of quantitation as low as possible so that we can kind of mirror the MRLs that we're looking for. If there's an MRL set at 0.01 parts per million, it's important that we can detect down to that low. So once we generated the raw data, we calculated that, and so we had 4 reps per sampling date for each of the sites. We averaged those reps, and then that's what forms the actual decline curves that I'm about to show you. And then also you'll notice on the curves, there's a 95% confidence interval. Those are the error bars that'll be on the curve. So we're looking at concentration over time declining. And we've also indicated on these graphs the PHI and the US tolerance, which we'll refer to as MRL, maximum residue limit. And then also on these slides, you'll see a table with MRLs for various countries. And one thing to keep in mind is that all values are in parts per million. So a little background on MRLs, or maximum residue limits. There's an allowable amount of pesticide in each country for each type of commodity and pesticide combination. Certain countries will set their own MRLs. Every country's different. Some countries don't set their own. They may default to Codex, which is an international body. Some countries where they don't establish MRLs, they have a default policy, like Japan, where Japan doesn't have an MRL set for a certain pesticide commodity combination. They default to 0.01 parts per million. Not all countries have a default. Taiwan is an example of a country that does not default. They have a zero default, or a zero tolerance policy. So there is no allowable limit for a pesticide that does not have an MRL in Taiwan. which is a little bit different than having the 0.01. So the source, the greatest source for MRL information is Bryant Christie. They have a website. They are the official source of MRL information. They contract with the USDA to provide such information, and you can go to their website, and if you sign up for a free subscription, you can access all of the MRLs. The only information that wouldn't be there is if a pesticide is exempt, or if the US does not have a tolerance for that pesticide, but another country might have a registration for that. Those would be the only pesticide, that'd be the only pesticide information you would not find on their website. This is a great source of information. All of the MRLs that will be in this presentation are current as of last month. Again, everything is in parts per million. Here I've got the guide that you will see. This is the table that will be on the remainder of the slides. And so these are the codes for all of these countries. And so the key to understanding this guide, we've got the US tolerances here. Everything in green should be good to go. Then you have different MRLs in orange, which would be moderately lower than the residues at PHI. And the MRLs in red are the ones that are kind of, bottom of the barrel sort of MRLs, anything lower than 0.1 parts per million. All right, so let's look at some examples of the insecticide decline that we looked at. So here is a recently registered insecticide, cyantraniliprole. And this is an example of a pesticide with slow decline. You can see that, these residues kind of over time, they take a while to decline. Again, just to orient you to these slides, this is has a 1-day PHI, and this little arrow is indicating that the US tolerance of 4 is much higher than the residues that we're seeing in this graph. And then here, of course, is the code for the years and the sites that we studied. So you can see also that probably because it is recently registered here in the US, there's not a lot of countries that have MRLs. So this is an example of one that not only does it decline slowly, but since there's not many MRLs, this could be of concern when you're exporting. So this is the type of data that we're generating. Moving on to another example of another slowly declining pesticide. Now the scale is a little bit different here, but you can see that fenpropyrethrin definitely hangs around over time. Okay. Most of the MRLs for fenpropyrethrin are achievable. There are some select markets of concern. Thank you for your help. So there are some markets of concern if you're going into Australia or the EU or Korea. That may be of more of a concern. One way to look at these slides as well is not just what is the residue at the PHI, but how long does it take for that residue to decline to get into the country that you're trying to ship to. So, for example, if you're trying to go to the EU, these residues out to day 21 are, they may not get below 0.01. So that would be a problem. This would be a product that you wouldn't want to use if you're going to the EU. But if you're going into Japan, well, that's a 5. So at no point did we have any residues above that level. So that would be fine to use fenpropyrethrin if you're looking to get into that market. Imidacloprid is another example of one where all the residues that we detected were well below the MRL or the tolerance of 2.5 for the US, but then most of the other countries are also amenable, China being the exception. But China doesn't really have a lot of MRLs established, so they're kind of an issue for export across the board, although there is some question about how much they actually test, so that's another thing. Malathion is an example of one that declines rapidly. It breaks down with UV light, and so this is a product that, you know, after 3 days, you could see that, you know, regardless of how high it started, it just drops like a rock. And so looking at the MRLs with this information, you know, no problem if you're going to Japan or even Canada. Now, if you wanted to get into Korea, this is shaded orange because, yes, it is at the PHI, it is below the residue levels that we're seeing. But if you just, maybe you don't harvest at the PHI, maybe you wait until day 5, and then that 0.5, which would be approximately right there, that may be acceptable to get into the Korean market. Spinosad is another example of one that declines fairly rapidly, and it is the only organic product that we evaluated. This is also an example of one that has different MRLs for raspberry and blackberry. This, well, being China. And this is also an example of one where we had different results for raspberry and blackberry that would affect the different recommendations. So for Australia, the MRL is 0.7 for both commodities, but we didn't detect any residues in the blackberries that were above that 0.7 mark. You can see all the green lines, which are the blackberries, are below that 0.7. So that's why that is shaded green, whereas the raspberry is shaded orange. All right, so we'll move on to an example of one of the miticides that we looked at. This is acequinacil, and another example of one that drops like a rock, essentially, in terms of its residues, but there's not a lot of MRLs that are established. So it's not the residues themselves, which are well below the MRL at the PHI, that you have to be concerned about. It's the fact that there's not MRLs established, or the MRLs are very, very low that are established. So we've got some fungicides to look at. First one being cyprodenol. And this is one that has moderate decline and is well below the tolerance. There are some markets of concern. This is one of the 2 AIs in the product switch. And so this one is going to be the one that's going to be more of an issue than the other component, which is fludeoxonil, and I'll be showing you that next. So because it declines a little bit more slowly than fludeoxonil, and some of these MRLs are lower, this could potentially, you know, be a concern. This is something that you definitely wouldn't want to harvest at the 0-day PHI if you're trying to get to Korea or Taiwan. You would want to wait, for example, for Taiwan at an MRL of 3. We do have this one line up here, but you might want to wait 7 days if you're going to use switch, if you can get into that market. So now let's take a look at the other component of switch, which is fludeoxonil. And so not only are these residues well below the MRL, but there's a lot of MRLs that are harmonized. So China, again, being the only concern there. So of the 2 components of switch, it's really the cyprodenol that you would be more concerned about. But there's not many barriers to using that product. Here is an example of a fungicide that we looked at, isofetamide, Kinja, where we observed some residues that at the PHI were above the MRL. So you can see this one line here is just above the US tolerance of 4 parts per million. And this is a relatively newer product. And so there's not a lot of MRLs that are established for this. Also, one thing about the isofetamide that is unique is that this has a longer PHI than most of the fungicides that we looked at. Most fungicides have a 0-day. We also looked at Captan, which had a 3-day PHI. And then this is the only one that has a 7-day PHI. So something to consider when using that product. And then here's the last example of a fungicide that we looked at. This is penthiopyrad, which I mentioned is not currently registered for caneberries, although the registration is coming. The tolerance has been set. And you can see this is another example of where we had residues that were well below the US tolerance. But again, because it's a new product, there's not a lot of MRLs that are set. So I imagine over time that will change. This is also a good example of a product that we added to the study in the second year. So we only have 2 years of data. We only have 2018 and 2019 for this. But we had some leftover funds from the 3-year project, and so we will be repeating this and some new AIs in 2020. So we'll be finishing out this data set next year. So that brings us to the end. I'd like to thank the Washington Red Raspberry Commission, Oregon Raspberry and Blackberry Commission. We had a task grant to fund this project. Thanks again to Randy Honkoop and Pete and Gina with OSU, and then my employee Hannah, who helped put this presentation together. So with that, I'll take any questions from the crowd. Any going once, going twice? Get the microphone coming over here.
Thank you. My question is just, do you take into account weather patterns when it comes to the decline rates of these pesticides? Because you figure that the temperature and like say the humidity and whatnot might affect how fast it declines, just because based on the half-life of the chemicals and whatnot. Or is that like someone else's, I guess, research project?
That's a good question. And I think that's something that we've talked about as a group, trying to evaluate this data of the impact that weather does have on these results. And so we have the 3 different locations, you know, one up here in Linden and the one, well, it's 2 locations, and then one down in Oregon. So that can kind of account for, you know, trying to represent the differences in weather. Also, we were noticing that 2019 was a very wet season, you know, unusually wet during the summer. And so we hope that by including multiple sites over multiple years, we're kind of capturing some of that variability in weather. But, and we do take notes on the weather events that happened during the trial. But as far as specifically saying that this 1 year is a result of more rain or not, we can't really conclude that.
Okay, thank you.
Mm-hmm. Any other questions? We have one right here. Oh.
Following up on the temperature, were adjuvants used in this trial? Spreader or sticker, any type of adjuvant?
You know, the field side, I don't believe Bev. Okay, according to Bev, we did not use any. We had questions over here.
You do work in tree fruit.
We do. So our laboratory, we specialize in pesticide residue analysis of food. Primarily, we work with the export market, and we do a lot of research. So we do work with, you know, apples, pears, cherries. I'm sorry? Okay, sounds good.
Were these efficacy studies conducted under GLP standards?
No. Our lab is very close to being GLP compliant, and we have rigorous standards that we follow. We are ISO 17025 accredited, and so we follow all of those guidelines when conducting the laboratory side of the research. I know that the field side probably mirrors close to GLP conditions, but no, technically it was not done as a GLP study. We would have charged a lot more money if we had. So, any other questions?
All right, thank you again.
Okay, thank you very much.